Hello, year threes. How's it going? Are you keeping well? Excellent. Welcome to another problem of the week with me, your host, Mr. Morrissey. Now, in this lesson, we're going to build on some of the learning we've been doing in recent weeks. We've been looking at so far equivalent fractions, that's right. And today we're going to look at comparing fractions. How exciting is that? Can't wait to get started. I bet you can't either. Well, let's begin the lesson then. We'll start with a quick recap of last week's learning. If you remember, we found various pairs of equivalent fractions, so fractions that are written differently but are worth exactly the same. And the challenge for you was to see if you could spot patterns and then come up with your own rule for creating equivalent fractions. So how do we find equivalent fractions? What's the rule? Can you remember? Maybe looking at these examples might refresh your memory. We compared the numerators and the denominators, and we saw that if you multiply both by the same thing, you will get an equivalent fraction. So here we multiply the numerators by 2 and the denominators by 2. So we know we'll get an equivalent fraction. So that's the rule. To find an equivalent fraction, multiply top and bottom by the same number. In this lesson, we're going to be comparing fractions. So saying whether one fraction is greater than or smaller than another one. We're going to start with a bit of an investigation. And again, like last week, I've got a challenge for you. Are you up to the challenge? Yes, of course you are. So by looking at these examples and then comparing and searching for patterns, can you come up with a rule, with a generalization that'll help us compare fractions? That is the challenge. Okay, now let's do our investigation. We're going to think about some parties. There's 4 parties going on here. You can see the number of children at each party. And you can see that at each party there is a cake. Now each cake is exactly the same, and that's really important. That allows us to compare them. Now the rule at this party is you have to share out the whole cake equally between all the people at the party. Okay, does that make sense? So no cake left over. Everybody has to get some. Everyone has to get the same amount. No cake left over. So what's that going to look like? Let's cut up these cakes. We'll do the slicing. So at party 1, how many people are there? There's 2 people at the party. That means 2 slices. The whole cake is going to be shared out equally between 2 people, 2 slices. So what might that look like? There's lots of ways of doing it, of course, but I'm going to cut across like this. Okay? So everybody gets one of those 2 slices. Party 2, how many people are we sharing the whole cake between? It's 3 people. So we're going to share out the whole cake equally between those 3 people. So that's how many slices? 3 slices. And we could do it something like this. Does that look pretty fair? We've cut up the cake into 3 equal slices. Everybody gets one of these slices. Next party, how many people are there? 4. So we need to cut up the cake into 4 equal slices. How would you do it? Let's see, there's lots of ways of doing it, but maybe I'll do a cut down here and a cut across here. Does that look pretty fair? 4 slices, 1 for each child. And finally, party 4, there are 5 children. So we're going to have to cut up the cake into 5 equal slices. Now, what do you think that looks like? It's trickier, isn't it? Maybe like this. Does that look reasonably fair? Excellent. Now, what patterns do you spot? Which children get the biggest slice of cake? What do you think? Can you see the slices? What happens to the slices when there's more children? They get smaller. So because there's only 2 children here sharing the whole cake between them, they get the biggest slice, isn't that right? But down here, there's 5 children all sharing the cake. So each gets a smaller slice. Does that make sense? Now let's think about fractions. What fraction is 1 slice? Well, we split the cake into 2 equal parts and we're looking at 1 slice. So 1 slice is half the cake. What about the rest? What about this one? Well, we're splitting up the cake into 3 equal parts and 1 slice. So that's 1/3. Here, 1 slices. Well, we've split the whole cake into 4 equal parts and we have 1 slice. So that's 1/4. And finally, we've split the cake into 5 equal parts. We've got 1 slice. So 1 slice is 1/5 of the whole cake. Now we're ready to do some comparing. Remember we said that these slices were the biggest of all, and these ones were the smallest. So we can say that a half is bigger than 1/5. Isn't that right? So the 4 fractions we had there, let's organize them from biggest to smallest. So what was the biggest of all? What was the biggest slice? The biggest slice was a half of the cake. The next biggest slice was 1/3 of the cake. The next biggest slice was 1/4 of the cake. And the smallest slice was 1/5 of the cake. Can you see what's going on here? Can you spot a pattern? Are you ready to come up with your own maths rule? Now it's important to notice what's the same and what's different. Here, the numerators are all 1. They're all the same. We call those unit fractions when the numerators are 1. And what's different? The denominators. So can you complete that sentence? The bigger the denominator, what? I'm going to give you my version of the rule in a moment. So if you want to stop and have a think about it, pause here. So this is what I noticed. The bigger the denominator, the smaller the fraction. Did you spot that as well? Well done if you did. Now the next question we always like to ask in maths is, why is that the case? Think about those cakes and splitting them up, slicing them up into equal parts. What does the denominator tell you? It tells you how many equal parts you've split the whole up into. So the bigger the denominator, we're splitting the whole into more equal parts. So more slices of the cake means each slice is smaller. Really hope that makes sense. Now remember, this is when the numerators are the same. That's important. So then thinking about that, can we compare these pairs of fractions in the circle? We'll put either smaller than, greater than, or equals to. What do you think goes here? Let's have a little think. Well, the numerators are the same, so we can just compare the denominators. Remember, the bigger the denominator, the smaller the fraction. So the smaller the denominator, the bigger the fraction. So 1/3 is greater than 1/6. If you have 1/3 of the cake, that's a bigger slice than 1/6 of the cake, isn't that right? Let's compare the second set of fractions, 1/8 and 1/5. What do you think? Is 1/8 greater than 1/5 or is 1/8 smaller than 1/5? It's smaller than, of course. The bigger the denominator, the smaller the fraction. 8 is bigger than 5, so 1/8 is smaller than 1/5. You're splitting the whole into more equal parts, so each part is smaller. Well done if you got those. Now, have a look here. What's different to what we've been looking at so far? Do you notice what's different to the previous examples? Let's look at the first one. We're comparing 1/3 and 2/3. So this time the numerators are different, but the denominators are the same. Same for the second one, 3/5 and 1/5. The numerators are different this time, the denominators are the same. How would you think about those? How would you compare them so you can decide which is the smaller fraction and which is the greater one? Well, this is how I might think about it. I might use bar models to represent the fractions and then see just by looking which one is smaller, which one is greater. So in this bar model here, the top one, I'm going to show 1/3. So I'm going to split the whole up into how many equal parts? 3, of course, because that's what the denominator means. And how many of those parts do I have if it's 1/3? Yeah, I've got 1 out of those 3 equal parts. So that is 1/3. Now I'm going to show 2/3. So I'm going to split the whole up into 3 equal parts. Again, the denominator is 3. Now the numerator is 2. I've got 2/3. So I've got 2 of these equal parts. So which is greater, 1/3 or 2/3? Well, you can see by looking, it's 2/3. It's 2 slices of the cake instead of only 1 slice of the cake. Isn't that right? So what symbol goes there? Smaller than. 1/3 is smaller than 2/3. Let's look at the second pair of fractions. We've got 3/5 compared to 1/5. Hopefully you can see and you can say straight away which one is greater, which one is smaller, because you understand what those fractions mean, what the denominators mean and what the numerators mean. But you could, of course, draw a representation. So how would we show 3/5? Well, we're going to split up our whole into 5 equal parts. And then we're going to shade in. How many of those? 3 of them. I've got 3 out of those 5 equal parts. 1, 2, 3. That's 3/5. And 1/5 is, I'm going to split the whole into 5 equal parts. But I have just 1 of those equal parts. So that's 1/5. So what can you say? 3/5 is greater than 1/5. What symbol goes here in the circle? It's the greater than symbol. Hope all that makes sense, because now I'm handing over to you. Time for those independent tasks. 2 here to begin with. So you can use strips of paper or draw bar models or other representations to help you with these. And for both questions, you need to complete the rules, a little bit like we've been looking at so far. Problems, 2 problems. So Sally makes a statement. Do you agree? Explain how you know. And then for the second one, what fraction could go in the missing box? How many can you find? Well, there's an almost limitless number of possibilities. So there's lots and lots to find. So really try to push yourselves to find another one, and then another one, and then another one, and then another one. I'm going to go through the answers to all those now in a moment. So if you're not ready, pause here and then go through them. Here we go. So number 1, I've put in these symbols there. I hope you agree. So you can use those fraction strips or use the rule we've already come up with. And then the sentence goes, when the numerators are the same, the bigger the denominator, the smaller the fraction. Or of course you could have it the other way around. When the numerators are the same, the smaller the denominator, the bigger the fraction. Number 2, I've put in those symbols. I hope you agree with me. And the rule, when the denominators are the same, the smaller the numerator, the smaller the fraction. Or the bigger the numerator, the bigger the fraction. Well done if you got all those. And then finally we have our problems. Some possible answers there. That's it for this lesson. I hope you enjoyed it, and I hope you're feeling proud of the work you've done and the effort you have put in, because that's really important. Don't forget to tune in next week for another Problem of the Week. And until then, take care. See you soon.